spring if we combine the spring to be a series structure, and then what will happen in the spring if we combine the spring, yeah, maybe not only two, but also we can combine 3, 4, 5, and more 5 springs. Yeah, basically the structure of spring, the spring has two structure. Those are series and parallel, and we will talk it later. And the ones that you have to know about the structure of spring is the pattern of spring, the pattern of series spring, and the pattern of parallel spring. Yeah, you have to familiar with this structure because basically both of them are different, but it's possible if one structure consists of series and parallel. Yeah, usually this structure called by mixed structure. Okay, mixed structure consists of series and parallel. Now we will talk about that. And then after spring, yeah, we will talk about stress, strain, and then the last one is modulus Young. So I hope you have to familiar like the definition of modulus Young, the definition of stress, and the definition of strain, and then how to apply of each formula to the questions. Yeah, how to analyze uh, modulus Young. Sorry, like the link among them, like the link between uh, modulus Young and stress, the link between modulus Young and strain, because the formula of modulus Young can be derived by the formula of strain and stress. Yeah, so like the combination between formula stress and stress will result will yield the formula of modulus Young. Okay, and then the last topics that we will learn in this chapter is about graph. Yeah, graph. I mean, like we talk about materials. Yeah, material, solid, and then elastic material, and then the plastic materials. But each material has uh, its pattern. It will be different if we talk about the pattern of elastic material and the pattern of solid material. It's clearly different because basically the characteristic of them are different. We know that the solid characteristic of solid, and we know that the characteristic of elastic material. So I hope you have to familiar with the pattern of each graph, like the solid graph and then the elastic graph, because these questions, these typical questions comes a lot of examination, Cambridge examination. Yeah, almost each year these questions comes up in Cambridge curriculum, Cambridge exam. Okay, so I hope you understand about this pattern. Wait. Okay, so I will start to explain By the way, can you see my slide, guys?
Yes.
Okay. Okay, now I told you, yeah, the topics that we will learn in this chapter and the introduction of deformation solid. Okay, now we start to talk about deformation solid. Yeah, and by the way, this is the characteristic of solid material. And by the way, I told you like the solid material relate to rigid body. Okay, now I think you know lah about this characteristic of solid material or solid body. Yeah, and always retain their original shapes. And for example, like how if I have two different material, yeah, and the first one, let's say iron material, and then the second one is rubber. Nah, actually, both of them are solid, yeah, are solid material, because yeah, if we see from its shapes, yeah, uh, iron and then the rubber shapes like solid material, and the distance between atom and the other atom, it's so close each other. Wait. Yeah, and this is the characteristic of solid. But basically,
Mister.
yes.
Maaf motong itu slide-nya masih di slide 1, terus nggak full screen.
Oh iya. Oh
Iya.
wait. Hmm. And then kalau sekarang
Udah gerak-gerak.
udah, udah ganti.
Udah ganti, Mister.
Okay, I try to make it full screen, and then you see the characteristic the deformation solid. Lihat ini enggak yang slide selanjutnya? Deformation solid relate to.
Full screen, Mister.
Oke deh. Hmm, sorry. Udah kelihatan sekarang. Okay. How about right now? Can you see my PowerPoint slide?
Udah, sir.
Okay, and then full screen.
Yes.
Okay, good. Okay, let's continue our discussion about the deformation solid. Yeah, and okay, this is the next slide. Yeah, deformation solid, and this is the characteristic of solid body. Yeah, the solid body. Now, as you can see, you can read the characteristic of solid body. Yeah, first is solid relate to rigid body. This means the distance among the uh, atom is close each other. Yeah, and then always retain their original shapes. And I think we agree with the second characteristic. And for example, yeah, let's say I have two material, yeah, different material. The first one, iron, and the second one about the rubber. Basically, both of them are solid material. Yeah, solid material, but both of them has different elasticity. Okay, and we know that the rubber more elastic than iron. Okay, so this chapter names about deformation solid. Yeah, the solid means the material we talk now is solid. Yeah, both of iron and rubber are solid, but the elasticity is different. Okay, we know. Yeah, I told you the rubber more elastic than iron. Okay, now if we talk about the iron, yeah, if you want to mix this iron or maybe destroy this iron, you need much power. Okay, maybe you need like hammer, or maybe you need like a drill to in order to make iron broke. But it will be different if you want to deform the rubber material. You need use your hand. Yeah, maybe you can pull this rubber with your force, natural force, and then what will happen? The rubber will longer than before. Yeah, so it's like the difference between elasticity characteristic iron and rubber. Yeah, and then cannot be deformed. I think sorry, I think this is not the right sentence. Yeah, this we can deform the material, but need much power. Okay, nah, if you want to deform uh, and yeah, and then the last characteristic of solid, it's possible to change their original shape or size through the application of an external force. Now, external force like I told you, yeah, external force means our force. Maybe we can use hammer and maybe we can use drill in order to change the original shapes. Okay, yeah. If you want to break the iron, yeah, you cannot use your natural force. You can, but you need much power, and it's like easier when you use hammer or maybe drill in order to make the material broke. Okay, and this is about the solid material. Now, let's talk about the stress. Okay, we start from the definition of stress. Basically, stress is a force acting on an object per unit of area. Yeah, this is the formula. Yeah, if you write the mathematic expression. By the way, this is the symbol of stress. F means force. Yeah, we know that the force units is Newton. Meanwhile, the area units is meter square. For an example, let's say this is my force. Yeah, this is my force F, and this is the area. Nah, okay, and this is the area square. Okay, nah, basically like this figure, yeah, the meaning of stress. Now, as you can see, stress is inverse proportional to area. So this means if you want to decrease the stress, you have to increase the area. Okay, the increase of area. But in other side, the stress is linear or proportional to force. This means the higher force, the higher stress. Okay, yeah, so this is the relation among them, yeah, between stress and area and between stress and force. F means force and the units is Newton, and then area units is meter square. So this means stress units is Newton per meter square. If you realize that the units of stress is the same as the units of pressure, not only the units, but also the pattern of formula stress is the same as pressure. Yeah, if you still remember that the pressure formula F per A as well. Okay, yeah, so I hope you remember about the formula of stress. And then the second one, let's talk about the strain. Strain is, as you can see, object has its shapes changed by force acting on it. Now, basically, strain can be calculated use this formula. And by the way, this is the symbol of strain. Yeah, delta L means change of length. Change can be extension and can be compression. Okay, and LO means initial length or original length. Okay, now from this formula, now I want to ask one of you, or maybe you can answer my questions directly. From this formula, what is the units of strain? Anyone can answer my questions? What is the units of strain? Before I call you, you can answer my questions directly. I told you, yeah, once again, delta L means change of length, and then LO means original length. So from this uh, magnitude, what is the units of strain? Okay, no one's want to answer my questions.
Is it unitless?
What?
nggak ada unitnya.
Nggak ada unitsnya, no units ya.
Soalnya
Okay.
kalau ada actually.
How you say like that?
Soalnya ini saya belum terlalu itu sih, tapi kan itu delta L length right per L O
Okay, by the way, ini siapa?
Santika Pak.
Okay. Yes, Santika.
Jadi itu kan kayak does it what's it called it
Yeah.
cancels itself.
Okay.
Apa
Yeah.
sih kalau
Yeah.
nggak salah?
Your answer is correct. Yeah. So from this formula, we can assume that this train no units. Yeah. Because why this train no has the units? Because delta L units is meter. Meanwhile, the original length units meter. Meter per meter is 1. So the strain has no units. Okay, thank you Santika for your answer. Okay, strain, this is the symbol of strain. Yeah, this is the extension. Can be extension and can be compression. Yeah, and delta L original length, and both of them has the same units. So the units of strain, yeah, no, no units for strain. Okay, now if you feel so, okay, let's say now let's say I have object and the object has L null. Okay, and then I pull this object with external force. Yeah, let's say the external force is F, and let's say this object is rubber. So this means the rubber will longer than original length. Nah, this is original length. Yeah, and this means start from this line until the end of this object. Yeah, this called by extension. Okay, delta L. If the original, yeah, if the original length, let's say 10 centimeter, and after I pull this object, yeah, the final length is 13 centimeter. This means the extension only 3 centimeter. Yeah, I hope you can you know the distinguish between final length and the change of length, yeah, or extension. Okay, yeah. So that's all about the strain. Okay, remember once again that the strain don't has a units. Okay, and the last is about Young modulus. Okay, Young modulus basically is the ratio of stress and strain. Yeah, so like this, the formula of modulus Young. Okay, And if you substitute the formula of each magnitude, stress and strain, as we knew that the stress is for force per area, meanwhile the strain is delta L per LO. And then let's substitute this formula to this equation. And then the equation, oh, no. Nah, we substitute this formula step by step. Yeah, firstly, let's say, let's substitute the stress first. F per area, yeah, and then substitute the strain. Strain is delta L per LO. Delta L per LO. Okay, and then this equals to force per area times LO per delta L. Yeah, and this is the final formula of modulus Young. Yeah, modulus Young can be calculated by using this formula. Force times LO per area times change of length. Okay. Nah, so this means the units of modulus Young only Newton per meter persegi. Ya. Okay. Example. Nah, example questions. A steel wire of diameter 1 millimeter and length 2.5 meter is suspended from a fixed point and mass of weight is 45 Newton is suspended from its free end, the Young free end. Okay, and the Young modulus of material is 2.1 times 1011 Pascal. By the way, Pascal equals to Newton per meter square. Yeah, and then the questions is please calculate stress, strain, and extension. Extension. Extension means delta L. Okay. So before you try to calculate the questions, you have to analyze from these questions what are information we obtained from these questions. Firstly, we know about the diameter of wire, 1 millimeter. Remember that you have to convert the units first before you do your calculation. And then after diameter, length, yeah, sorry, length, and then this one, mass, yeah, the weight, and then modulus Young. Okay, so from these questions, we only know 4 datas. Yeah, diameter, length, weight, and modulus Young of material. Now, firstly, and there are 3 questions: stress, strain, and extension. Okay. Uh, okay. So before I uh, explain about this example, I think it's better if you try first lah. Try first ya. Oke guys, coba dulu. Then we discuss together. Okay guys, if you have a questions, maybe you can ask me. But if you can, okay, continue your calculation. How guys? Is anyone can answer? By the way, how about the formula? Maybe maybe you can write the formula first, and then I will move to the next slide in order to show you the questions. Wait a minute. Okay, I will move to the next slide. I will wait until 5 minutes more. Is anyone finish this example? This example questions? If you finish, you can mention your result, stress, trend, and extension. Okay, how about Naura? Naura?
Belum selesai,
Naura?
Mister.
Oh, belum selesai. And then, how about Kayla?
Udah, Mister.
Udah, good. Stresnya berapa?
Stresnya 8,4 kali 10 pangkat 6.
Terus strainnya?
Strainnya 4 kali 10 pangkat min 5.
And then, extension? Extensionnya kumaha? Kayla, extensionnya? Udah.
Kayak saya salah ngitung deh, Mister.
Gak apa-apa tuh. Oke, thank you Kayla. eh Coba saya mau ke Raka. Raka udah belum nih?
Belum selesai, Mister.
Belum selesai. Oke, saya mau ke ini. Fahreza. Fahreza ada?
Saya juga belum selesai, Mister.
Belum selesai. Oke. Oke, kayaknya lebih baik kita bahas aja. Lagi pula ini cuman example ya. Okay, at least thank you. Yeah, you try to finish these example questions. Okay, I told you we obtained 4 information from these questions. Those are diameter, length, and then weight, and the last one is Young modulus. Nah, we want to calculate the stress. Remember, stress is F per area. We knew about the force. Yeah, the force is the same as weight because the unit is the same. But we only know about the diameter. So this means you have to calculate the area of a circle first. Yeah. Okay, area PR square. If the diameter is 1 millimeter, this means the radius of wire is, you just divide by 2. Okay, and don't forget to convert the units. Yeah, the units still millimeter. Millimeter to meter is times 10 minus third. Okay, and this is the radius after the diameter divided by 2. Yeah, and don't forget to square because the formula is PR square. Should be 3.14. And then after you calculate this equation, you will obtain the result is equals to 7.9 times 10 minus 7 meter square. After you obtain the area, you can use the formula of stress in order to know the value of stress. Yeah, you just substitute the number that you knew from the questions like weight and then the area, yeah, and then you will obtain the number of 5.7 times 10 positive 7 Newton per meter square. Or if you want to write the units of stress Pascal, it doesn't matter, yeah, it's okay. Because between the Pascal and also Newton meter square is the same. Nah, okay, so it's clear about the stress, okay? And then how about the strain? Yeah, remember from these questions we know about Young modulus, which means the Young modulus formula is oh okay. Basically, we obtained this formula from this equation. Yeah, remember that the Young modulus is equals to stress divided by strain. Yeah, and we obtained the stress, yeah, from previous calculation, and our goals is want to know about the strain. So the simple, you just change the position between Young modulus and strain. Yeah, so the equation will be like this. And then yeah, you just substitute your number. Yeah, and then the Young modulus is 2.1, and then you will obtain the result of strain. Remember the strain that has units. Yeah. Okay, so we only and then this is the condition of spring depends on extension or compression. Okay, at the first condition, without extension or compression, this means at this point, potential energy equals to 0. But after the spring longer than before, basically potential energy has two formulas. Yeah, and I will tell you potential energy on spring. First, this one, yeah, and then this one. How we obtain this formula? Okay, let's check from this the first formula. The formula of potential energy of spring is 1/2 constant of spring times delta x square. Nah, what if I separate this delta x. Delta x square. Nah, I read the delta x square in the other way, yeah, and this is the same. Delta x times delta x means delta x square. Okay. Nah, if you realize that, nah, what is this formula? Constant times delta x. I think this is the same as this formula. Ya kan? Ya, 1/2 K delta X. And this is force. Nah, okay. So that's why I told you there are two formula of potential energy. Sometimes you can solve the questions use this formula, and sometimes you must to use this formula. Yeah, so it's depend on the information you obtained from the questions. Yeah, like conditional. Okay, now, but both of this formula depends on the extension or maybe the compression. Remember, if the condition of spring without the extension, this means the potential energy always equals to 0. Okay, okay, guys. I think it's enough for today. Yeah, and we will discuss further about this chapter in the next meeting. Okay. Nah, and I hope you. Okay. Wait. Okay. Nah, yeah. So the conclusion of today is about the stress, strain, and then young modulus